Hi again. Let's solve another problem using Euler's equations. Consider a cylinder. Imagine you are in a cylindrical world. You're moving on the outer surface of this cylinder, and you want to go from point 1 to point 2 in the minimum distance. The minimum distance between 2 points on a surface is called a geodesic. So we want to find the shape of a geodesic on the surface of a cylinder. The first thing you need to do is to write the element of distance in this surface. The element of distance is ds equal to the square root of dx squared plus dy squared plus dz squared. But because of the symmetry and because you are taking a course on classical mechanics, you choose to work in cylindrical coordinates. So the radial distance rho is constant, so ds is this square root here. Now, because you want to minimize the distance to travel, you actually want to minimize this integral, but you need to write it in terms of just one variable. To do so, you will divide by d phi, and to the derivative of dz over d phi, you will call it z prime. Here, phi is the parameter of integration, z is the quantity that depends on that parameter, and z prime is the rate of change of the quantity with respect to the parameter. You now want to minimize s. You call f to the function inside the integral, and you will use Euler's equations for that. Since the partial of f with respect to z is 0, then this expression is constant. Let's call it z. Now, you want to solve this equation for z prime. So as rho and c are constants, z prime happens to be also constant, but z prime is dz over d phi. For any point along the path, z and phi change at the same rate. This can be written parametrically as. And this is the equation of a helix, so that the geodesic along a cylindrical surface is a helix. You have to run on the angular direction phi at the same rate as you go up in the z direction. May the science be with you.